So let's now see how we can delete the last node of the singly linked list, but we're gonna use only one single pointer. So instead of using two pointers, we're gonna use only one single pointer. So in the linked list we have three nodes. So let's just remove this last node. So first of all, we have to check if the head is null or not. So we are basically going to check if the list is empty or not. So if the head is null, that means the list is empty. So we don't have to perform any deletion, we're just gonna simply return null. And also in a case where we have only one node, then we're just gonna free the memory allocated by this node and we're gonna return null. In other cases where we have multiple nodes, then we have to use one pointer. So a pointer which is initially pointing to this first node, and then we have to use the loop and we're gonna move that pointer before the last node. So that means this is the last node. So we're gonna stop this pointer before the last node. So first of all, we're gonna free the memory allocated by the last node. So we're gonna use free and then current arrow link. So this will free the memory allocated by the last node. And then we have to remove this link. So we're gonna set current arrow link equal null. That means this link will be removed and we're gonna have null. So this node will be removed from the linked list. So here we're gonna define the function to delete last node using one single pointer. So the function will return struct node type pointer. So we're gonna call the function del last. So the function will take one struct node type pointer head. So first of all, we're gonna check if the list is empty or not. So if the head node is null, that means the list is empty. So we're gonna simply print list is empty. So we don't have to perform any deletion, we're just gonna simply return null. And in a case we have only single node in the list, so in that case we're gonna check if the head link is null. So if the head link is null, that means we have only one single node. So in that case we're just gonna free the memory allocated by that single node and then we're just gonna return null. In all other cases where we have multiple nodes in the list, so in that case we're gonna use one temporary pointer. So struct node type pointer, we're gonna call this current. So this will initially point to head. So this current will initially point to the first node, which is the head. Now we have to traverse through the list. So we're gonna use the while loop and here we're gonna check if the current's link's link, if that is not equal null. So as long as the current pointer's link's link is not null, so we're basically saying that we're gonna continue the loop as long as we reach the second last node. That means the node before the last node. So inside the loop we're just gonna move the current pointer. So current equal current arrow link. So whenever this loop ends, the current pointer will reach the node before the last node. So when we reach that point, so here we have to free the memory. So we're gonna free the memory that is allocated by the last node. So the current's link mean the last node. So we are freeing the memory allocated by the last node. So now we have to remove the link to the last node. We have to set current link and we're gonna set this to null. So that means the link will be removed and this node will have null as the link. So we're now simply going to return the new head pointer after the removal. So now if we print the linked list, so you can see the linked list has 3 nodes. So let's now delete the last node. We're gonna pass the head pointer and this will return the new head pointer after the removal. So let's now print the entire linked list again. So after the removal, you can see the last node is removed from the linked list. So this is the way we can use one single pointer and we can remove the last node from the singly linked list. So hope you understand the concept. See you in the next one. Take care.